All right, let's get into it. Okay, today we are going to move forward in our project timeline and we're going to start working on our stretch goals, which is what makes our project the most immersive experience that it can be. But first, let's kind of reminisce and see how much you've already done up to this point, because it's a lot. You worked with others to create your concept, then you prototyped your mechanisms and affordances, then you prototyped your hardware and your code. So you have already done so much. But now we really want to work on polishing and stretching and preparing for our final presentations for this last week. So we can really clearly communicate to everybody, to us, how much work that you all really put into it, because I know all of you put a bunch of work into it. So how we polish and how we kind of accomplish our stretch goals and our enclosure and practice our presentation and format our code, that's going to be what communicates how much work you've put into this project, which is important because you're taking a class and we're going to grade you. So first, we're going to talk about ways to kind of stretch the ability of piezos and LEDs and other materials in order to communicate our story and our affordance design to the best of our ability, since we're working under such tight constraints. Then we're going to look at some of these hardware and software skills that you have used in media and technology and see how they've been applied in the art world. Just to remind you all how cool these skills that you've learned really are. So, okay, first let's talk about piezos. It is true. Our piezos are pretty constrained as far as like what kind of noises it can make. It'd be like beep, boop, boop, bop. So, I mean, especially compared to like a full orchestra, but that's okay. That's okay because we can code our little beep, beep, boop, bops to make them emulate a tune that a user has already experienced and try to link those emotions that came with that full music experience by like coding our piezos to replicate that tune. So music makes the user feel something, and although the piezo is kind of constrained, we can still evoke emotion with it. Here's some examples. Maybe we want to make like a user chuckle, right? We can have them remember the Me Channel's theme song. Like it's not, funny as is, but it's funny because it's connected to that point in our lives. Be like, oh my God, Me's. Maybe we want the user to experience like intense joy. We can replicate Beethoven as best as we can. Maybe we want the user to feel like kind of suspicious. We could maybe, be the Pink Panther song. I don't know. All of this code, though, all of these links here, the code's already written for you. All you have to do is merely copy and paste it into your project and make sure all of the right pins are properly defined. We can have examples of like hopeful or spooky, like Hedwig's theme in Harry Potter, or evil, in the Imperial March, like we think of Darth Vader, which, by the way, when I was a child and into my adolescence, called Dark Vader. It was a sad day when I realized that was wrong. So now let's transition to how we can use the LEDs to the best of our ability. So we want to integrate our LEDs into our projects in meaningful ways that indicate user progress, create an immersive environment that's communicated by your enclosure, and provide feedback on the choices that the user made, whether the outcome is good or bad. So a user generally knows that red means stop and green means go. We can assume that. We can also extrapolate this correlation and use it to communicate success or failure by linking these with our affordance design. And by linking these with our affordance design, I mean we can embed these LEDs into other kind of components of our enclosure that we've designed to indicate what a user should do or results of a user choice. We can also program our LEDs to do things in the background, and it doesn't necessarily need to rely on the user closing a switch. So we, for example, could create like a starry night sky by coding a sequential or randomized light show. We could potentially embed a line of LEDs into like a cardboard lightning strike, and try to emulate that burst of energy by coding the lights to light up downward. There's lots of ways that we can use LEDs even if it's not reactive to a user closing a switch. It could just be looped the entire time. So let's also think of providing user feedback. So constant user feedback is a huge factor in user experience and user design. So LEDs could be integrated into the cardboard. You could create potentially a dynamic key or mini map of your project that's communicating to a user where they are in your story. For example, let's say a user is progressing through a maze, and the position of the user is determined by what switches have been completed. If you're at the beginning of the maze, or the middle, or the end. And the position of the user can be displayed in this kind of key in the bottom right or left-hand corner by lighting an LED in a certain position of this mini maze or this key. You don't have to do it exactly like this, but it's just a thought. Also, remember our magical closet in that classroom is full of stuff. You can find materials around campus and all over out at the store. Materials everywhere, right? So don't just think that you're constrained only to cardboard and paint and the skewers. We can use whatever material we want. So materials like yarn and foam and cotton can be used to maybe potentially create a scene where the rain falls after a servo is pulled from the ceiling of the enclosure, releasing this like mobile of clouds and raindrops, if you can imagine that. So imagine like everything is kind of crunched up at the top. There's a ceiling, a flat piece of cardboard that's holding it and hiding it from the user. Servo spins, and you've kind of created a pulley system where the ceiling kind of pulls out and then the rain falls down. I know another group was talking about trying to emulate that by making a bunch of little balloons, kind of like they do it sometimes at concerts where the balloons are all in this net and they pull the net out and they fly down onto the crowd. And that's a pretty amazing experience, right? So we could try to do something like that with other materials. We can also use aluminum foil instead of copper tape because it is a conductive material. So this allows you to have a little bit more flexibility with creating interactive switches, and it can let us mess around with movement in a really fun way if we have that flexibility by using aluminum foil instead of just the flat copper tape. Finally, we will never stop reminding you how cool these hardware and software skills are. The possibilities are truly endless. Here's just a few that I really like. The 4-letter words is like an installment by Rob Stewart he used the Arduino and processing to kind of create this moving installation, and each kind of like linear LED kind of tube moved, and the installation itself could spell like any word, because it could kind of emulate any letter, but it just created a really cool exhibit. The second one is Inform, and this is a dynamic shape display that can render 3D content physically. This could be like data, so that users can interact with this digital information in a really tangible way. And fun fact, their initial attempt at prototyping this interface was called Contour, like our favorite professor. And then finally, this last one, if you haven't seen it, I highly recommend you look it up. Maybe we'll look it up in a second, actually. This is a beautiful installation. It was a robotic sculpture created by Sun Yuan and Peng Yu. And this robot has one specific duty, and it is to contain this viscous, deep red liquid within a predetermined area. So when the sensors detect that the fluid has strayed too far, then the arm kind of frenetically like shovels it back into place, and it leaves these smudges on the ground, and it splashes the walls, and it creates like a super visceral emotional experience. Kind of feels like the robot is trying to keep itself alive, and it's just a constant struggle. I'm gonna look it up because it really is incredible. That's just a picture. There we go.
Don't lose your when
Always
building an
ads.
online store.
So these artists worked with electrical and mechanical robotics engineers to create this installation. Pretty incredible. It's just awesome to see that the skills that you are learning in this class can be continued to be worked on, and something as amazing and immersive and emotionally provoking can be made out of these skills. It's the art in AET. Okay, so before I show you the brief discussion assignment that we're going to have, I just want to remind you all that you're doing really great and we're very proud of you. And let's just push it as hard as we can as we are getting to the end of the semester. You really are so close. You're awesome. I wrote it down. You're awesome. Okay, let's check out the discussion. So if we go to Canvas, we can go to discussions. This is going to be published and live by the time that we get this video out to you, but you can just see here, Project 2, Stretch Goals Discussion. What I want you to do is prove that you watched this very brief lecture by typing what your least favorite song reference was, and then we want you to post an idea for a stretch goal for your project. So remember, each member should have their own post, so y'all should think of some different stretch goals, and then you can kind of come together and decide which one you would like to tackle. Or once, maybe you do them all. It's a possibility. All right. See you all. We're on Discord if you need us. Bye.